Helion's groundbreaking announcement, world's first commercial nuclear fusion plant to rise in Malaga, Washington by 2028. On February 28, 2025, Helion Energy, an innovative fusion energy company based in Everett, Washington, made a significant announcement regarding its ambitious plans to construct the world's first commercial nuclear fusion power plant in Malaga, Washington. This groundbreaking project is poised to begin construction in the summer of 2025 and aims to commence fusion energy production by 2028, marking a pivotal moment in the energy sector's shift towards sustainable and carbon-free solutions. Project Overview. The proposed nuclear fusion plant is expected to have a capacity of 50 megawatts MW and is strategically located on land owned by the Chelan Public Utility District (PUD) near the Rock Island Dam along the Columbia River. Although the site has not yet been officially finalized, Helion is actively engaging with the local community and plans to host a community event on March 11, 2025 to discuss the project and gather feedback from residents. Timeline and construction plans. Helion has set an ambitious timeline for the project, aiming to begin construction in mid-2025 pending the successful completion of necessary permitting processes. If these timelines are adhered to, the facility could begin generating fusion energy by 2028, potentially transforming the energy landscape both locally and nationally. Funding and strategic partnerships. To support this monumental project, Helion recently raised $425 million in a Series F funding round, bringing its total funding to over $1 billion. This substantial financial backing is critical for advancing Helion's fusion technology and developing the necessary infrastructure for the plant. A notable strategic partnership with Microsoft established in May 2023 highlights the significance of this project. Under this agreement, Helion aims to provide Microsoft with clean electricity generated from the fusion plant, aligning with Microsoft's sustainability goals and further emphasizing the commercial viability of fusion energy. Economic and community impact. The construction of the fusion power plant is expected to create approximately 130 jobs during the building phase, with around 30 permanent positions needed for ongoing operations once the facility is operational. This job creation is particularly significant for Chelan County, where the local economy has historically relied heavily on hydropower. The project aligns with Chelan PUD's vision to diversify energy sources and reduce dependency on a single energy source, addressing future energy demands and enhancing regional energy stability. Community engagement and support. Recognizing the importance of community involvement, Helion has committed to engaging local residents throughout the project planning process. The upcoming community event at Mission View Elementary School will provide residents with an opportunity to learn more about the project, ask questions, and express their views. This inclusive approach is designed to foster transparency and build trust between Helion and the local community. Technological advancements and challenges. Helion is not alone in its quest to achieve nuclear fusion as a practical energy source. Several other companies and research institutions are also working on fusion technology. The challenges of achieving sustained fusion reactions that produce more energy than they consume remain significant. However, Helion's latest prototype, known as Polaris, aims to demonstrate the feasibility of generating usable electricity through fusion. The company's progress in fusion technology will be closely monitored as it advances toward its operational goals. Conclusion. Helion Energy's announcement of the world's first commercial nuclear fusion power plant in Malaga, Washington represents a monumental step toward realizing the potential of fusion energy as a sustainable and carbon-free power source. With a focus on community engagement, significant funding, and strategic partnerships, Helion is poised to not only revolutionize energy production but also contribute to the broader goals of sustainability and energy diversification in the region. As the project progresses, it will undoubtedly serve as a beacon of innovation in the energy sector, inspiring future endeavors in clean energy technology. Counterintuitive information in Helion's announcement on nuclear fusion plant. 1. Nuclear fusion versus traditional nuclear power. While nuclear energy typically conjures images of hazardous waste and catastrophic failures as seen with fission reactors, the announcement of a nuclear fusion plant, particularly one emphasizing safety and sustainability, challenges the conventional narrative that nuclear energy is inherently dangerous. Fusion, unlike fission, produces minimal radioactive waste and has no risk of a runaway chain reaction, presenting a paradox where the term nuclear is usually associated with danger, yet fusion could offer a safer alternative. 2. Corporate involvement in energy solutions. The partnership with Microsoft may seem counterintuitive given the tech giant's focus on software and digital services. However, it illustrates a growing trend where technology companies are directly investing in energy infrastructure to secure reliable and sustainable energy sources. This move highlights a shift in the energy landscape where tech companies are not just consumers of energy but are actively involved in its production, contradicting the traditional view that energy generation is solely the domain of utility companies. 3. Community engagement in high-tech projects. The announcement emphasizes community involvement and transparency, which is often overlooked in high-tech energy projects. Normally, such projects proceed with minimal public input due to their complexity and technical nature. Helion's approach to engage local residents and gather feedback is a departure from the norm, suggesting a more democratic process in energy development that contrasts with historical patterns of top-down decision-making in industrial projects. For job creation in high-tech energy sectors, the potential creation of 130 construction jobs and 30 operational roles at a fusion plant may seem modest compared to the economic impact of fossil fuel industries. However, this counters the narrative that high-tech energy sectors cannot provide substantial employment. It suggests that emerging fields like fusion energy could contribute significantly to local economies while promoting sustainability, challenging the perception that transitioning to green energy necessarily leads to job losses in traditional sectors. 5. The urgency of timelines in energy development. The ambitious timeline of commencing construction by summer 2025 and generating energy by 2028 may appear overly optimistic, especially given the historical delays in energy project approvals and construction. This contrasts with the general expectation that groundbreaking innovations in energy technology are often met with prolonged regulatory processes. Helion's confidence in meeting these deadlines reflects a shift in the regulatory environment where the company's strategic planning, which may not align with past experiences in the energy sector. 6. Investment in fusion technology. The scale of investment, with over $1 billion raised, challenges the skepticism often associated with fusion technology's viability. Historically, fusion has been viewed as a scientific endeavor with limited commercial prospects. Helion's ability to attract significant funding suggests a growing confidence among investors in the commercial potential of fusion energy, contradicting prior beliefs that fusion was perpetually decades away from practical application. 7. Focus on carbon-free energy. The emphasis on pursuing a fusion plant as a cornerstone for carbon-free energy solutions is counterintuitive, considering that many still view nuclear energy, even fusion, as a stopgap rather than a long-term solution. This perspective challenges the prevailing narrative that renewable sources like solar and wind are the only viable paths to a sustainable energy future, positing that advanced nuclear technologies could play an equally crucial role. 8. The role of hydropower in energy transition. Helion PUD's acknowledgement that it has all of its eggs in one basket with hydropower may seem surprising given the region's historical reliance on this renewable source. The shift to diversify energy sources indicates a growing recognition that even renewable energy systems need to be diversified to ensure long-term sustainability and reliability. This insight counters the assumption that reliance on one renewable source is sufficient for a sustainable future. By highlighting these counterintuitive aspects, Helion's announcement not only signals a significant advancement in energy technology but also challenges existing perceptions and assumptions about energy production, corporate responsibility, and community involvement in the transition to sustainable energy sources. Important content in Helion's announcement on the fusion plant. While the report on Helion Energy's announcement regarding the world's first commercial nuclear fusion plant in Malaga, Washington highlights several crucial aspects, there are important details that many might overlook. Here are the key overlooked elements and their significance. 1. Community engagement and involvement. Significance: Helion's emphasis on community engagement is essential for the project's acceptance and sustainability. The planned community event on March 11, 2025 serves as a platform for residents to voice their concerns, ask questions, and gain insights into the project. This proactive approach can help mitigate potential opposition and foster a sense of ownership among local residents. Why it matters: community support can significantly influence regulatory approvals and project timelines. Engaging local stakeholders early helps address concerns about safety, environmental impact, and economic benefits, which can ultimately lead to smoother project execution. 2. Strategic location near hydropower. Significance: the choice of location near the Rock Island Dam and on land owned by Helion PUD highlights a strategic move to integrate fusion energy with existing hydropower infrastructure. This geographical advantage could facilitate the management of energy supply and demand while providing a complementary energy source. Why it matters: this integration could enhance the reliability of the energy grid and promote a diversified energy portfolio for the region, reducing reliance on a single energy source and improving resilience against potential energy shortages. 3. Microsoft partnership as a catalyst. Significance: the partnership with Microsoft represents not just a commercial agreement but also a validation of Helion's technology and its potential role in corporate sustainability efforts. This alliance could lead to further investments and collaborations in the clean energy sector. Why it matters: corporate partnerships can accelerate technological advancement and deployment by providing not only financial backing but also expertise in scaling operations. Microsoft's commitment to purchasing fusion energy highlights the growing demand for clean energy solutions and sets a precedent for similar agreements in other industries. 4. Job creation and economic impact. Significance: the forecasted creation of approximately 130 jobs during construction and 30 ongoing positions post-completion underscores the local economic impact of the project. This aspect is crucial for garnering community support and demonstrating the project's tangible benefits. Why it matters: job creation can influence public sentiment positively, as local residents see direct benefits to their economy. Furthermore, these jobs can help foster a skilled workforce and emerging technologies, potentially leading to further innovations and developments in the region. 5. Innovation in energy production. Significance: Helion's approach to nuclear fusion is not just about producing electricity, it represents a shift toward a more sustainable carbon-free energy future. The development of a 50 megawatts fusion plant could serve as a model for future energy projects globally. Why it matters: this innovation could significantly alter the energy landscape, providing a cleaner alternative to fossil fuels and contributing to global efforts in combating climate change. The successful implementation of fusion energy could push other companies and nations to invest in similar technologies, accelerating the transition to renewable energy sources. 6. Regulatory challenges and permitting process. Significance: the necessity for environmental impact assessments and permits is a critical phase that could delay the project's timeline. While the report mentions the timeline for construction, it does not delve into the complexities of the permitting process and potential regulatory hurdles. Why it matters: understanding the regulatory landscape is vital for stakeholders, as delays in permitting can impact funding, community support, and construction schedules. Proactive engagement with regulatory bodies and anticipation of potential challenges can help streamline this process. 7. Global competition in fusion technology. Significance: the report briefly mentions the competition Helion faces in the race to develop functional fusion reactors. However, the implications of this competition are profound, as they highlight the urgency and importance of achieving breakthroughs in fusion technology. Why it matters. The global race for fusion energy is not just about technological supremacy, it involves national energy security, economic leadership, and environmental responsibility. Awareness of this competitive landscape can drive investment and innovation, motivating stakeholders to support Helion's efforts. Conclusion. The announcement by Helion Energy about the establishment of the world's first commercial nuclear fusion plant is a landmark development with far-reaching implications. While the report covers various essential aspects, the overlooked elements such as community engagement, strategic location, corporate partnerships, job creation, innovation, regulatory challenges, and global competition are significant. They highlight the complexity of bringing such an ambitious project to fruition and the broader impacts on the local community economy and global energy landscape. Understanding these nuances is crucial for stakeholders as they navigate the future of energy production and consumption. 1. Significance of the project. Helion Energy's plan to construct the world's first commercial nuclear fusion plant in Malaga, Washington represents a monumental step in the push for sustainable energy solutions. Unlike traditional nuclear fission, fusion promises a cleaner and virtually limitless source of energy by mimicking the processes that power the sun. This project not only has the potential to revolutionize the energy landscape but also aligns with global efforts to combat climate change. The plant's proposed capacity of 50 megawatts, specifically aimed at supplying electricity to Microsoft's data centers, underscores the practical application of fusion technology in meeting modern energy demands. 2. Community engagement and economic impact. Helion's approach to community involvement is crucial for the project's success. Scheduled community events, such as the one on March 11, 2025, indicate the company's commitment to transparency and local input, which can foster public trust and support. The anticipated creation of approximately 130 jobs during the construction phase and around 30 permanent positions post-completion highlights the project's potential positive impact on the local economy. Moreover, Helion PUD's intention to diversify energy sources beyond hydropower reflects an adaptive strategy in response to future energy demands and climate challenges. 3. Funding and strategic partnerships. The recent Series F funding round, which raised $425 million, bringing Helion's total funding to over $1 billion, is a testament to investor confidence in the viability of fusion technology. Furthermore, the partnership with Microsoft, which marks the first commercial agreement for fusion energy, signifies a pivotal moment in the energy sector. This collaboration not only reinforces Helion's financial backing but also aligns with Microsoft's sustainability goals, showcasing how corporate partnerships can drive innovation and enhance the feasibility of groundbreaking technologies. 4. Regulatory and technical challenges. Although the project is ambitious, it faces significant regulatory and technical hurdles. The need for environmental impact assessments and permitting processes is critical before construction can commence. The urgency of meeting the 2028 timeline for energy production means that Helion must navigate these challenges efficiently and effectively. Additionally, achieving a sustained nuclear fusion reaction that can generate usable electricity remains a complex technical challenge. Competing entities in the fusion energy sector further complicate the landscape, making Helion's progress a focal point for industry observers and stakeholders interested in the future of energy production. These 4 points encapsulate the project's significance, its economic implications, the strategic partnerships that elevate its potential, and the challenges it faces, offering a comprehensive foundation for deeper analysis and discussion. 1. The Manhattan Project, 1942 to 1945. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. It involved collaboration between the United States, the United Kingdom, and Canada, culminating in the construction of atomic bombs that were dropped on Hiroshima and Nagasaki in 1945. This monumental project not only showcased the potential of nuclear fission but also had profound implications for energy generation and military strategy in the subsequent Cold War era. The project's success and the subsequent nuclear arms race underscored the dual-use nature of nuclear technology. similar to the potential dual-use implications of nuclear fusion technology today. 2. The Apollo Program 1961–1972. The Apollo program was a series of missions launched by NASA with the goal of landing a human on the Moon and returning them safely to Earth. It is best known for the Apollo 11 mission in 1969 when astronauts Neil Armstrong and Buzz Aldrin became the first and second humans to walk on the lunar surface. The program represented a significant technological achievement and a major milestone in human exploration fueled by a strong national commitment in funding. The collaborative efforts of scientists, engineers, and policymakers in the Apollo program resonate with the current collaborative initiatives surrounding Helion's nuclear fusion project, which involves partnerships with corporate entities like Microsoft aimed at achieving sustainable energy solutions. 3. The ITER Project, International Thermonuclear Experimental Reactor, launched in 1985 and still ongoing. The ITER project is an international collaborative effort to build the world's largest experimental fusion reactor in France. It aims to demonstrate the feasibility of nuclear fusion as a large-scale and carbon-free source of energy. The project involves multiple countries including the EU, the United States, Russia, China, India, Japan, and South Korea. ITER represents a significant step toward harnessing fusion energy for commercial use, much like Helion's plans for a commercial fusion plant in Malaga, Washington. Both initiatives reflect the global pursuit of clean energy solutions, highlighting the challenges and potential breakthroughs in nuclear fusion technology. Future outlook: predictions for Helion's commercial nuclear fusion plant in Malaga, Washington. The announcement by Helion Energy to build the world's first commercial nuclear fusion plant in Malaga, Washington marks a significant pivot in the global energy landscape. As the project progresses toward its 2028 operational goal, several key predictions can be made regarding its implications for energy production, technological advancements, economic impacts, and environmental sustainability. 1. Technological advancements in fusion energy. The successful construction and operation of Helion's fusion plant could catalyze rapid advancements in fusion technology. As the company aims to demonstrate a viable commercial fusion reactor, it will likely spur innovations in plasma physics, materials science, and engineering. This could lead to enhanced reactor designs. The knowledge gained from Helion's Polaris reactor and subsequent prototypes will inform the design of future reactors, potentially leading to smaller, more efficient, and more cost-effective fusion systems. Increased research funding. A successful operational plant can attract additional private investment and governmental funding into fusion research, encouraging collaboration between academia, industry, and government. 2. Impact on energy markets and policy. Helion's plant could significantly influence energy markets and policies, especially regarding carbon neutrality. Disruption of traditional energy sources. As fusion energy becomes commercially viable, it could reduce dependency on fossil fuels and even some renewable sources, reshaping energy portfolios worldwide. This disruption may prompt traditional energy companies to invest more heavily in fusion or integrate hybrid systems. Policy frameworks. Governments may introduce new regulations and incentives promoting fusion energy development. The success of Helion's plant could lead to a broader acceptance and integration of fusion energy into national energy strategies, influencing global energy policies towards sustainability. 3. Economic growth and job creation. The construction and operation of the fusion plant are expected to create significant economic benefits for the local community and beyond. Job creation. With approximately 130 construction jobs and around 30 operational positions, the plant will stimulate local employment. This could also lead to growth in related sectors such as manufacturing and technical services. As the demand for specialized components and expertise increases. Local economic boost. The investment in the plant and associated infrastructure will likely boost the local economy with increased spending in the region and potential development of new businesses catering to the workforce and operational needs of the fusion plant. 4. Environmental impact and carbon neutrality. One of the most promising aspects of fusion energy is its potential for sustainability. Reduction of carbon footprint. If Helion's plant operates as intended, it could produce clean carbon-free energy, significantly contributing to global efforts to reduce greenhouse gas emissions. This aligns with the increasing urgency to combat climate change. Waste management. Fusion energy produces minimal radioactive waste compared to traditional nuclear fission. The successful implementation of this plant could set a precedent for future nuclear projects, emphasizing the importance of sustainable waste management practices. 5. Community engagement and public perception. The community engagement initiatives surrounding the project will play a crucial role in its success. Building local support. Helion's proactive approach in involving local residents in discussions will foster a sense of ownership and support for the project, potentially mitigating opposition and addressing concerns about safety and environmental impacts. Shaping public perception of nuclear energy. A successful fusion project could alter public perception of nuclear energy from fear and skepticism to acceptance and enthusiasm, paving the way for future nuclear projects. 6. Global influence and competition. Helion's project could position the United States at the forefront of a new energy revolution. International collaboration. As other countries pursue fusion energy, Helion's success may lead to international collaborations and partnerships, enhancing technological exchange and setting global standards for fusion energy production. Competitive edge. If Helion can establish itself as a leader in fusion technology, it may provide the U.S. with a competitive advantage in the global energy market, influencing energy exports and international energy relations. Conclusion. The Helion fusion power plant in Malaga, Washington represents a pivotal moment in the transition to sustainable energy solutions. As the project unfolds, it holds the potential not only to revolutionize energy production but also to significantly impact economies, environmental policies, and public perceptions of nuclear energy. The next few years will be critical in shaping the future landscape of energy, and Helion's initiative could serve as a beacon for the global transition towards a cleaner, more sustainable energy future.